Okay, so far we have done it. We have estimated this system unrestricted VAR model, right? We have already estimated unrestricted VAR model, right? And unrestricted VAR model, and we have three variables such as GDP, consumption, and import, right? That we have checked already. Unrestricted VAR model, GDP, consumption, and import, and this is the outcome of the unrestricted VAR model, right? And that we have already seen, right? Outcome of the unrestricted VAR model, right? That we have seen already. And here we have seen that we have three model. That is the first model, and where the GDP is the dependent variable, right? GDP is the dependent variable. And the second model is this one. The consumption is the dependent variable. And what about the third one? Import, right? Import is the dependent variable. Okay, now we want to check whether individually, now I talk about individually, whether individually, suppose I take GDP, individually, how is this model? That means diagnostic checking. Individually, how is this model? That is meaning that GDP model, right? Okay. So what I do, okay, and also I shall check individually how is this model. That is where the this one is the dependent variable, meaning that consumption is the dependent variable. And also I shall check individually how is this model. That is import is the dependent variable. So first I start with this one, GDP. Okay, what I do, I make a selection, right? I make a selection and I copy it. I copy the whole models. Okay, I copy it. Then after copying it, after copy the GDP, then I open quick, then I choose estimate equations, and here I paste it. I paste it whatever I copied. I just paste it. I choose the paste, right? I paste it. The whole thing has come. So now I set the things so that I can estimate it. I set it like this. I set it, right? I set it like this so that I can estimate it. Okay, set it. Okay, I've set it right like this, right? Meaning that I'm following this setting. You can see Y C1 C2, right? I follow this guideline that is given here, right? And I set it accordingly. So here I can make it zoom so that you can see better. See, I have set it, the whole things. And here GDP is the dependent variable, right? And all are independent variable, lag 1, lag 2, right? So here I have C7, right? So this is my model, right? This is my model, and so on, right? Okay, now I shall be estimating it. I shall estimate it. Okay, so I press OK. I press OK. Okay, this is my estimation of the model, right? You can see from here. this is the estimation of my model. You can see the dependent variable is GDP, right? And this is my model actually, right? Okay. Now here you can see, okay, now I shall be doing the diagnostic checking. That means how is it as a model? Diagnostic checking. Okay, how it is as a model, that we shall do now. Okay, okay, first I check, okay, and you can see the result, okay, and you can see the result are here, right? This is the outcomes. Okay, okay, so here what about C1? C1 is the coefficient of GDP lag 1. C2 is the coefficient of GDP lag 2. C3 is the coefficient of consumption lag 1. And C4 is the coefficient of consumption lag 2. C5 is the coefficient of import lag 1. C6 is the coefficient of import lag 2. And finally the constant C7. Okay, and these are the outcomes C1, C2, C3, C4 until C7. So these are the coefficient. Okay, now I check how many variables are significant here. So we can know it from p-value. From the probability value we can know it. But here you check all the p-value is more than 5%, meaning that none of the variable is significant. So that is a very bad side of this model. None of the variable is significant to explain the dependent variable, that is GDP. None of the independent variable is significant to explain the dependent variable, that is GDP. Okay. Okay. Then you just wait 1 minute. I'm just giving like just 1 second. Okay, then I'm just saying that is okay, then then what is happening here? Okay, so none of the variable is significant individually. That is a bad sign, very bad sign. Okay, then we can check jointly. Jointly, how many variables are significant? Suppose we choose consumption lag 1. Suppose I choose this one, import lag 1 and import lag 2, right? Is this two variable jointly significant? We can also do it by the wall test, right? We can also check by the wall test whether import lag 1 and import lag 2 jointly can influence GDP or not. We can do it also, but how we can do it? How we can do it? So I go to the as before. So as before, I go to view, then coefficient as before. So here I can take the world statistics as before. So I choose the, I'm doing again, so whether import lag 1 and import lag 2 jointly can influence GDP or not. So we can appoint the world test, world coefficient test. World coefficient test we can choose to get the job done. So the null hypothesis is import lag 1 and import lag 2 jointly can influence GDP or not, right? That we can do now, meaning that suppose we set the null hypothesis. The null hypothesis here that C5 equal to C6, I can put it 0, right? C5, C6 equal to 0. So that is the null hypothesis. Suppose we cannot reject null hypothesis. That means if we accept null hypothesis, meaning that C5 and C6 are 0, meaning that import lag 1 and import lag 2 jointly cannot influence our dependent variable, that is GDP. Okay, so I go to view to test it, then I go to coefficient diagnostic as before, then I choose wall test, right, as before, then I set the hypothesis C5 equal to C6 equal to 0, right, equal to 0. I set the hypothesis, right, whether they are jointly 0 or not. So here you can see wall test, right, chi-square and the p-value and the null hypothesis. So here the p-value is how much? 55.47%, which is more than 5%. So we cannot reject null hypothesis, meaning that we accept null hypothesis, meaning that C5 and C6 is 0. Meaning that, meaning what? Meaning that we can see last time, meaning that C5, C6, 0, meaning that import lag 1 and import lag 2 jointly cannot influence our dependent variable, which is GDP. So what is here decision? Import lag 1 and import lag 2 individually they cannot influence GDP. At the same time, import lag 1 and import lag 2 jointly also cannot influence GDP. That means individually they cannot influence and jointly also they cannot influence. So that is the decision here. Okay, then I talk about other things such as I talk about R square of the whole model of this GDP model. R square is quite high, 86.37%. So we are happy about it. It is quite high, 86.37%. So meaning that the model is better fitted. Normally, if the R square is more than 60%, we are happy, but here 86.37%. So we are quite happy. So that is the good side of this model. But bad side is F statistics. You see F statistics and corresponding p-value. How much is the p-value? 35.54%. So 35.54%, which is more than 5%. So F statistics is not significant. So that is a bad side of this model, right? F statistics is not significant. Okay, then I check whether this model has serial correlation or not, whether this model has heteroscedasticity or not, and we also check whether the residual is normally distributed or not. Okay, I check one by one. I go to view, then residual diagnostic. First I check serial correlations, right? Because this one is the time series data, so probably serial correlation is there. Normally, if the data is time series, normally the time series model is affected by serial correlations normally. So I check it first. Okay, suppose I choose lag 2, right? Then I okay. So I choose lag 2. So the okay, suppose sorry, I've come here to wrong place. Okay, no, sorry, I've come wrong place. Okay, I go to my model. Where is my model? I just go there, work files. Because the data is not sufficient to estimate the serial correlation. Okay, I do it again. Nothing to worry. I can do it again. The data is not sufficient. Okay, no problem. I can do it again. Where's the models? Okay, just 1 minute. Data is not sufficient to estimate the. Our data is only how many? Our data is only 11 or 12, right? That is not sufficient to check the just 1 minute, to check the serial correlations. So what I do, I try again. I go to view, residual diagnostic, serial correlation. Okay, here I took lag 1, not 2, right? Because our data is not sufficient to check the serial correlation. So I took lag 1, then I check. Yes. Okay, here the serial correlation, Bush-Godfrey serial correlations, observed R square and the corresponding p-value. How much is it? 83.29%. 83.29%, which is more than 5%, meaning that we cannot reject null hypothesis. And what is our null hypothesis? The null hypothesis is there is no serial correlation in the residual of this model, and that is desirable. There should not be any serial correlations. So we are happy about this model because there is no serial correlations. Okay, then we can check whether there is heteroscedasticity or not. And normally, time series data do not have heteroscedasticity. But still, we can check it. I go to view, then residual diagnostic, then heteroscedasticity test, right? And here I choose the first one, Bush-Godfrey test, right? The first one I choose, okay. And this is the Bush-Godfrey test of heteroscedasticity. And I choose this one, observed R square and corresponding p-value. What is the p-value? 29.47%, which is more than 5%. So we cannot reject null hypothesis. What is our null hypothesis? The null hypothesis is there is no heteroscedasticity and we cannot reject it. So we are happy about this model because there is no heteroscedasticity in the residual of this model, and that is desirable. So we are happy about the model. Okay, finally we can check whether the residual is normally distributed or not. That we want to check finally. So I go to view, then residual diagnostic, then I check this one, test of normality, right? So this is the outcome, and here is the Jarka-Bera statistics, you can see, and corresponding p-value, right? How much is the probability value? Here we can see the probability value is 79.08%. 79.08%, which is more than 5%, meaning that we cannot reject null hypothesis. And what is our null hypothesis? The null hypothesis is that residuals are normally distributed and we cannot reject it, and that is desirable, that residual should be normally distributed and we cannot reject it. So we are happy about this GDP model. Why? Because residuals are normally distributed. Okay, so I talk about this model, as a GDP model, how it is. Okay, number one, this model has no serial correlation, so we are happy about it. This model has no heteroscedasticity, so we are happy about it. This model, residuals are normally distributed, so we are happy about it. This model, R squared is very high, we are happy about it. But the problem is that in this model, F statistics is not significant. So that is the bad side of this model. And second most important bad side, none of the independent variables are significant to explain the dependent variable. That is the greatest problem of this model. So I am telling again, what is the main problem of this model? None of the independent variables, meaning that I can show you in this model, you can see none of the independent variable is significant. So that is the very bad side of this model. So we cannot accept this model as a whole because none of the independent variable is significant. So my suspect actually that this model is suffering from problem of multicollinearity. I guess this model is suffering from problem of multicollinearity, right? Multicollinearity, right? And that is why, because of this problem, none of the variable has become significant. That is my suspect, right? That is my suspect, that here is a problem of multicollinearity, right? And I think if this problem is removed, if the problem of multicollinearity is removed, then I think few variables will become significant, but we have to remove it, right? Okay, so the GDP variable is done, our first model is done, right? Okay, then what about a second model? Second model, I think that is the consumption model and we can check it, right? We can check the consumption model about the consumption model. So meaning that this one, okay, that is our second model. To check how is this model as a model, how it is. So I copy the whole things. I copy the model and then I go to quick estimate equations as before. I paste it here as before. Then I arrange it as before, right? Then I run it. Consumption. I set it. Otherwise, we cannot estimate it, right? Settings should be very proper, right? So that is my setting already, and I can zoom it for you. You can see the whole things. That is my second model, right? I set it already. That is the zoom, right? Okay. So now I can estimate it. Okay, this is the outcome of the consumption model, right? Okay. So here I check also what is happening here. I just set it. Just 1 minute. I just set it. How to set it? Okay. I just set it. Consumption model, right? I just set it. 1 minute. Okay, here you can see that our consumption model, here you can see that, just go down. Okay, you can see the first thing is that you can see the probability value, none of the variables are significant. So that is a very bad side and we cannot accept the model. You can see all the p-values are more than 5%. So I suspect that there is a problem of multicollinearity, and if the multicollinearity is removed or handled, I think some of the variables will become significant. So that is a very bad side of this model. We cannot accept this model. And secondly, the R square is very low, 59.95%. We are not happy about it. And the F statistics is not significant, right? That is a bad side. You can see from here. It is 78.44%. So it is not significant at all. So that is a bad side also. Okay, then I talk about the residual. I go to view, residual diagnostic. First I check serial correlations, right? Okay, here I choose lag 1 because our sample size is very small. So I choose lag 1, right? Not lag 2. Okay, here is the outcomes. You can see the Bush-Godfrey test, right? The Bush-Godfrey. You can see from here. I just adjust, just 1 minute. I adjust it slightly. Not coming up. Okay, I do some adjustment. Okay, I put the p-value, right? Okay, here you can see here. Okay, okay, here is the Bush-Godfrey test. Observed R square, corresponding p-value. So so we cannot reject null hypothesis, meaning that we accept null hypothesis, meaning that there is no serial correlation. So we are happy about the model. Then I talk about the second one, residual diagnostic, heteroscedasticity, right? We check it. Okay, and we choose Bush-Pagan-Godfrey as before. Okay, and that is the result. Bush-Pagan-Godfrey, observed R square, corresponding p-value. So the p-value is not also significant, meaning that there is no heteroscedasticity. So we are happy about the model. And finally, I check the test of normality, right? That is the last test of the residual. And here is the Jarkabera statistics and corresponding p-value. So the how much it is? The probability value is 74.65%, right? Which is, so as a result we cannot reject null hypothesis, meaning that residuals are normally distributed. So we are happy about it. Okay, so it is the second model. What about our last model, that is import? I check our last model. So I go to system equation, right? So that is our last model, right? Import is the dependent variable. So I copy the import, right? I copy it. I copy the whole things as before. Then I go to quick estimate equations and I paste it here. I paste it here, and then I arrange it. I arrange it as before, right? I arrange it. Okay, just slowly. You have to arrange very slowly, otherwise I know. Otherwise you may face problems. So yes, it is done. Set. Then I okay. Okay, it is the outcome of the import, right? The dependent variable is import. And here what is happening? See? You can see from here none of the independent variable is significant, meaning that here is a problem of multicollinearity. And r squared is also small, and the probability value is not significant. So we cannot accept the model because none of the independent variable is significant. So we cannot accept the model. At the very beginning, we cannot accept the model. Okay, what is the guideline? The guideline is that most of the independent variable should be significant to become a good regression model. Suppose example, here is 1, 2, 3, 4, 5, 6, 7. So out of 7, at least 4 should be significant. Out of 7, at least 4 should be significant to become a good regression model. At least 4. At least 50 to 60%. At least 50 to 60% of the independent variable should be significant to become a good regression model. But here none is significant, so we cannot accept the model. Okay, then we check the residual matters. I go to view residual diagnostic. Okay, first I check serial correlations, and here I choose lag 1. Okay, you can see the serial correlations. Okay, observed r square and corresponding p-value. Okay, what is the p-value here? 0.39%. 0.39%, which is less than 5%, meaning that we can reject the null hypothesis, meaning that there is serial correlation in the residual of this model, and that is not desirable because we can reject the null hypothesis. So there is serial correlations, and that is not desirable. So that is bad side of this model. Okay, then I talk about the heteroscedasticity. We check it. Okay, we take the observed r square And the p-value we cannot reject, meaning that there is no heteroscedasticity. So we are happy about it. That there is no heteroscedasticity. And finally we check the normality, right? Normality. Here the Jarkabera statistics corresponding p-value. How much is the p-value? 80.58%, meaning that we cannot reject null hypothesis, meaning that the residuals are normally distributed, and that is desirable. So we are happy about it because residuals are normally distributed. Okay, this model has mainly two problems. Number one problem, that no independent variable is significant. So we cannot accept the problem. So probably there is a problem of multicollinearity. That is why none of the variable has become significant. And another problem of this model, or of this import model, that is I say that the import is the dependent variable of this model. Another problem is that there is serial correlations in the residual, and that is not desirable. Thank you very much for being with me for a while. Good luck. The terms of uses, right? You can see.